Section 1.3 Properties of Matter. Every substance has a unique set of properties. For example, the properties listed in Table 1.3 below allow us to distinguish hydrogen, oxygen, and water from one another. The properties of the matter can be categorized as physical or chemical. Physical properties can be observed without changing the identity and composition of the substance. These properties include color, odor, density, melting point, boiling point, and hardness. Chemical properties describe a way a substance may not change or react to form other substances. A common chemical property is flammability, the ability of a substance to burn in the presence of oxygen. Some properties, such as temperature, melting point, and density, are called intensive properties. They do not depend on the amount of sample being examined and are particularly useful in chemistry because many of these properties can be used to identify substances. Extensive properties of substances depend on the quantity of the sample, with two examples being mass and volume. Extensive properties relate to the amount of substance present. Figure 1.10, a chemical reaction. Hydrogen gas and oxygen gas burns to form water, which is produced in the flame. Topic 1. Physical and chemical changes. As with the properties of a substance, the changes that substances undergo can be classified as either physical or chemical. During a physical change, a substance changes its physical appearance but not its composition. That is, it is the same substance before and after the change. The evaporation of water is a physical change. When water evaporates, it changes from the liquid state to the gas state, but is still composed of water molecules, as depicted earlier in Figure 1.4. All changes of state, for example from liquid to gas or from liquid to solid, are physical changes. In a chemical change, also called a chemical reaction, a substance is transformed into a chemically different substance. When hydrogen burns in air, for example, it undergoes a chemical change because it combines with oxygen to form water. The molecular view of the process is depicted in Figure 110. Chemical changes can be dramatic. In the account that follows, Ira Remsen, author of a popular chemistry text published in 1901, describes his first experience with chemical reactions. The chemical reaction that he observed is shown in Figure 111. While reading a textbook of chemistry, I came upon the statement nitric acid reacts with copper, and I determined to see what this meant. Having located some nitric acid, I had only to learn what the words act upon meant. In the interest of knowledge, I was willing to sacrifice one of my few copper cents then in my possession. I put one of them on the table, opened up the bottle labeled nitric acid, poured some on the liquid on the copper, and prepared to make an observation. But what was this wonderful thing which I beheld? The scent was already changed, and it was no small change either. A green-blue liquid foamed and fumed over the scent and over the table. The air became colored dark red. How could I stop this? I tried by picking up the scent and throwing it out the window. I learned another fact. Nitric acid acts upon fingers. The pain led to another unpremeditated experiment. I drew my fingers across my trousers and discovered that nitric acid acts upon trousers. That was the most impressive experiment I've ever performed. I tell it even now with interest. It was the relation to me. Plainly, the only way to learn about such remarkable kinds of actions is to see the results, to experiment, to work in the laboratory.